Finding antiderivatives numerically. Before we start talking about how to find an antiderivative using Excel, let's just go through a simple example that we can do by hand, and then we can repeat that in Excel to make sure that we get the right answer, and to also see how the accuracy will improve as we improve our estimate in Excel. So let's suppose that we're given a velocity as a function of time of some particle, and we know that that will be the derivative of the position, and we're told that it is equal to 3t squared, an easy enough function to take an antiderivative of. So we're also told that x at 0, the initial position of the particle, is 1. So given this information, let's find the position of the particle x at time 3. Okay, so the first thing we can do is we can write down x of t in general, and we know that this has to be of the form t cubed. And now, because derivatives kill off constants, we must allow for a general constant to be added to this. And we don't know what that constant is, but we can find it because we know where the position of the particle was originally. So let's plug in our initial time t equals 0 into the position function that we've found, and that means that we've got 0 cubed plus c. And because we were told the initial position of the particle was 1, we can set this equal to 1. Well, that just means that c must be equal to 1. So we have x of t equal t cubed plus 1. Now, if we verify the position at 3, we can plug in t equal 3 here, and that tells us that the position is at t cubed, which is 3 cubed plus 1. 3 cubed is 27 plus 1 is 28. So that means we expect to get the answer 28 from any attempt to find this answer numerically. Okay, so let's go over to Excel and see if we can do that. So just for reference, let's put a few things up here in the top corner. First, that x prime of t was given to us as 3t squared, and we also were told that x of 0 was equal to 1, and we are interested in x of 3. That's just for reference. So now let's add a little section here where we include all the numbers that we're going to need. So that includes t0, which is 0, t final, which is 3, and then using those we're going to have to define a dt, but first we have to decide how many intervals we want to break 0 to 3 up into, and let's start off with something simple, just 10, and our dt will be defined by all of those numbers. In particular, we want to take 3 and subtract off 0, and then divide that into the total number of intervals we chose. And now if I change 10 to 20, it'll automatically update dt for me. So let's leave it at 10 for now. And then one other piece of information that we're going to need, we want to have x of 0 on hand, so let's put that down here, and that is 1. Okay, so now that we have all that info down, let's put down data for these functions. So we have to get t in a column, x prime in a column, and then using those we'll get x of t. So t is going to start at t0, which is in B5, and then we're going to increment that, taking the previous cell and add to it delta t, which is in B8. And now we're going to repeat that all the way down until we get to 3. Now x prime, we know that it's 3 times the t value is just in the neighboring cell, which in this case is C2, and we're going to take that squared. And now let's copy that all the way down, and we get all our t value, x prime values at t. Now for calculating x of t. So when t is equal to 0, we know that we should just be referring to our initial value, which is x of 0 is 1. Oops. And then from then on, we're going to use an update that's based on knowing the derivative. So let's switch back over to our blackboard or whiteboard here and go through and figure out what we should be including in that cell.